All right, there we go. How are you? I hope everybody's well. Good, good. Hopefully everybody's doing well. Hopefully your good afternoon. I'm assuming most of you got my email there. No, your computer's not glitching there, Jess. I did change the date of the test to next week. You weren't hallucinating. I I had some concerns, and then I was like, yeah, everybody needs to kind of ease into the transition a little bit. So, yeah. Hello, morning. How are you? We'll wait for a few more minutes here. So, good, good. I did, Chase. I did, my friend. I had to, I had to, I had to make sure to go back to my original roots, my bald roots. It's kind of important there. Gotta, gotta get the little thing there. uh, oh, thank you. The answer to your question there, Planet, is yes. The test has been extended to next Tuesday. Yes, next Tuesday. The homework was extended to next Monday. The test there till next Tuesday. So, yeah, there's that thing. Yes. So that's what's going on there. Wait another couple minutes here, and then we'll go ahead and get started with the new material. Hello, Alyssa. I'm doing really good this week. How are you? I hope you got the email there. Yes. So yeah, let me go ahead and get started here. At this juncture. Um, yeah, let me get this out of this out of the way. So everybody should thank Alyssa because she sent me an email saying kind of deadlines and stuff. So I gave it some consideration and I looked at the grade book and stuff. Hey JTS. And I kind of decided, yeah, I'll extend the homework out for another 6 days, and I'll extend the test out for another week. So yeah, that's pretty much what I decided to do. Now, yeah, you can use it to study a little bit more, and then you can kind of get it out of the way once you're done with that. There was a few there are a few things that basically kind of made it. I had to make some tweaks, not in the test, of course, but on the back end for the Respondus monitor stuff. So I made a couple tweaks to make it a little bit more accessible. But I want to be sure that everybody at least gets the first test done so you can get a proper grade on it. Still get your two chances, right? You still have your ridiculous amount of time. So you should still, I haven't changed those whatsoever. I just changed the date back. So by next Tuesday at 11:59 on the 29th is when the test will be due. Again, by the 28th is when the chapter Unit 1, Unit 2 test will, Unit 1, Unit 2 homework, excuse me, will be due. And then starting from the 29th, Unit 3 will be opened after that. It's based on how the system works. So once we get to Unit 3 there, then, yep, that'll be going on. The homework will be open until next Monday. Test next Tuesday. No problem. You definitely deserve an explanation about what's going on. I sent you all an email through your student mail through D2L there, so probably if you haven't read your email yet, you probably will see it from me. So I just recently sent it like an hour ago or so. So if you haven't read your email, that's understandable. Does anybody else have any other questions? I hope that's okay. Everybody good? Hey, that's right. Hey, man. Gotta make it crystal clear. Gotta be transparent, man. That's how it works. Again, I just want to be sure everybody. Well, you asked, Alyssa, so there you go. I told you I'd give it due consideration, and there you go. Due consideration was made. Any other questions you guys got? No problem. Sometimes I gotta look at the big picture here, and I gotta make adjustments. So it always happens every class. So no biggie. Asking is never a bad thing. I'm sympathetic to the cause. Any other questions, anybody, before we get started? Okay, so let's go ahead and get started here. I have no idea. All right, let me put this on my phone here. Okay, good stuff. All right, we can do that. All right. What are we going to learn about today? We're getting into a new chapter here today, Jess. Let's do it. All right. We're getting into this stuff here. Let's do it. All right. So let's do this. All right. Okay, let's get started today. Welcome back to Tuesday. Hopefully, you're having a nice weekend. So today, we're going to start a brand new chapter here in Chapter 3. Oh man, Chapter 3 is the place to be. All right, so today we're going to hopefully get through a section or a section and a half or something to that effect of a Chapter 3. Maybe we'll get through the whole thing. I don't know if we will, but we'll go ahead and give it a shot. All right. In any case, today we're going to be talking about quadratic functions and all their stuff and doodads. And then we'll be talking about polynomials in section 3.2 and all their stuff and doodads. All right, so we have lots of doodads to talk about. All right, specifically. All right, so let's go ahead and do that here right now. All right. So first, let's talk about quadratic functions. Oh boy, I know everybody's so excited. I can sense the excitement already. All right, not really. All right, let's look. Let's go to question number 1 here. What is the general form of a quadratic function? All right. So let's go ahead and put this out here. Oh, there it is. Okay. So what's the general form of a quadratic function? Well, most of you know what the general form of a quadratic function is going to look like. All right. And let's just make sure I get that. Okay, good. All right. So make sure I don't mess those two up. All right. So we have ax squared plus bx plus c. Now you've seen this before back in chapter 1. Okay, so this shouldn't be anything brand new to you guys. You've seen this before. Again, what have we seen here in terms of functions here specifically? Well, what we do know is, like, say, an example here would be, say, f of x equal, actually, probably should put that on math type. Would be a good idea. All right. All right, so we have f of x here equals, 2x squared minus 5x plus 7. Okay, so here's an example, all right, of a quadratic function. We've worked with this before. We found out how to get zeros, using the quadratic formula. We kind of worked with that already. So I'm not going to go over that stuff here because that's not the purpose of this section, but that's the general gist. Now, what we are going to focus on here is really going to revolve around, in this particular section, is going to revolve around some of the properties of quadratic functions. So the next part here is going to be very different, okay? And it talks about what's the standard form of a quadratic function. So let's go ahead and describe the standard form of quadratic function. So the standard form of quadratic function is going to look like this, and it's going to look very different than that of the kind of the regular general form that we're normally used to. So it's going to look like this. We have a times x minus h quantity squared plus k. Okay. All right. So this is going to be the standard form of the quadratic function. Now, of course, we're going to need to go ahead and make some descriptions here, because you can't just throw out letters magically and say, oh yeah, this comes from out of nowhere, okay? So let's go ahead and describe what each of these letters mean in relation to what we want to talk about here. Okay, so first things first here, a is going to be a multiplier, okay? We're going to get a little bit more into a here in another question here later on in this handout, so you'll see where that's located. However, I do want to focus here on h and k, so let's focus on h and k here specifically because that is actually really important here. So h and k here, specifically, this is going to be referencing the vertex. Okay, so this is the, let's put this in this. Okay, so this is the vertex, okay, of the parabola. Okay, so every quadratic function is a parabola of some type, but specifically, this is the vertex of the parabola is h comma k. Now, one thing to keep in note here, and this is actually a rather important note, so I'm going to add it here. Note, uh, if be very careful how you look at h and k. What I mean is that if you see you have x minus h quantities squared, so h is always opposite of what is written. Okay, k stays the same, but h, you have x minus h. So if you have, say, x minus 5, then h is 5. Okay, so you have to be really careful about that when you go ahead and want to take a look at what the xy coordinate is going to be for the vertex of that particular graph. Okay? Okay, so there are various ways to write it into general form. We're going to take a look on how to do that. We'll see exactly what's going on with that. Okay, now this is kind of a little bit of information dump. What is a vertex again? Let's go with that here. Did I not put that? Okay. I would say kind of the center of the parabola, but another way to kind of highlight vertex here would be the highest or lowest point on a parabola. So the best way to kind of put this is basically the good old phrase, the top of a hill or a bottom of a bowl. Okay, so you can kind of imagine it that way. That's where the vertex is going to be. Okay, so that's kind of like the pure kind of definition there of the vertex. So we're going to be looking at that, of course, in a graphing kind of way, but we'll take a look at that afterwards because we have a few more things to do. All right, let's go ahead and let's go ahead and take a look here at this next question because we're going to need to start putting some things together here about how this is going to work and how we can read these guys. So, all right. Alrighty. So, okay. Next question. Okay. How do we go from general to standard form? So we're going to go from this form here, ax squared plus bx plus c, and we're going to go to this form here, a times x minus h quantity squared plus k. All right, let's talk about the key here in this case. So the key here in this case into changing from general to standard form is using a friend that we may not like but is absolutely necessary here, and that is so what you need to do is you need to complete the square, but on only one side of the equation. Okay? So that's kind of the difference here. We need to complete the square, but only on one side of the equation. Okay, now we're going to take a look at this, and once we're finished with that, we also going to get a little bit of information here that'll help us answer the next question as well. Okay. Okay, where is it? There we go. Okay, so let's go ahead and do an example. All right, we're going to start with a standard form, and we're going to go from a general form to a standard form. So let's do our example here. So let's say f of x equals, let's go with a nice one at least here to start with a bit. Okay. Okay, that's fine. Okay, so here's our example here. F of x is equal to 2x squared minus 8x plus 3. Okay, so that shouldn't be too much of a problem. All right, at least to write down. Now, let's talk about how we can complete the square. Now, the key part here, and let me go ahead and emphasize this, the key part here is going to be, the key part here is going to be this last part of this definition, and that is only one side of the equation. All right, you are only allowed to work on one side of the equation. So anything here, this f of x part, is out. You cannot use anything here to the left. Everything that's going to happen in this particular problem is going to happen over here to the right. Okay, so what happens when we go ahead and do that? Well, let's go ahead and go over how we can get doing the completing the square on just one side of the equation. So first and foremost here, let's remind ourselves one important thing to completing the square. Remember that if you have a coefficient, or again a number, in front of x squared, that we have to effectively factor that out. However, we're only going to factor out from the first two terms. So what's this going to look like here? Here in step 1, we're going to take out the 2 if necessary. So we're going to have 2, we'll have x squared minus 4x, and then we'll leave a little space here. And then we'll have the plus 3 out here. Okay, so we've just went ahead and did that here. So basically, this is, again, I'll put this down here. If there is a number in front of x squared, then factor it out regardless as your first step from the x's. All right, so here we factored out the 2, and we had x squared minus 4x. So we separated the x's, and we kept the number separate as well. Now we go ahead and take our b term here. That b term's still the same here, but still minus 4 here, so we're going to take not the same, but we're going to take minus 4, we're going to divide that by 2, and we're going to square it. Okay, so we got minus 2 squared here, in this case, which equals 4. So in this case here, we're going to take this, in this case here, we get 4. Now, the real issue is what happens after that. So let's go to step 3. Step 3 is we need to add 4 inside here, okay? So we're going to add 4 here. Okay, so actually, let me write that in the next line there. So we have 2 x squared minus 4x. Leave a little space there, plus 3. I'll change that back to red. So we're going to put a plus 4 here. Now, what we have to do is, if you recall what we did last time, is we added the same number on the other side, right? That's what we did to kind of properly compensate on the other side, to balance it out. However, understand that we're only allowed to work on one side of the equation, right? That's the key here, right? We can only work on one side. So I'm not allowed to go to the f of x side. So that's a common mistake I see a lot of people, is like, oh, you just add something to the f of x. Like, no, it's not what you do. That's correct, Gura. That's absolutely correct. So in this case, we're going to subtract by the amount that we added in. In this case, as correctly stated, it is minus 8. The reason why it's minus 8 is because we have the 2 on the outside and the plus 4. So if we distributed the 2 here, we'd actually are adding 8 on the inside here. Okay, so just be careful about that. at 2 and 4 here. That's why we have the 8 minus 8 out here instead. So here we are going ahead and subtracting the same amount on the outside. Okay, that's what we're doing here in this case. Okay, so to show off the next step here, let's go ahead and do this out. So to show off this next step here, we're going to just factor. So we get 2, and we factor x squared minus 4x plus 4, which we already know by default is going to be this minus 2 based on completing the square. So you get x minus 2 quantity squared, and then you add up on the outside here, which is minus 5. Okay, so that's how we get this into standard form from the general form. Okay, are there any questions so far about that? No? Okay. Now let's answer a question here. What is the vertex? What is the vertex of this particular equation? What's the vertex? What's the vertex of this parabola here, based on this equation we just found? 2 comma minus 5. Yes, that's correct. Nice. So we want 2 comma minus 5 here. So the only two numbers we care about are this minus 2 up here. That's this minus 2. You take the opposite of that. So the opposite of that, because that's how the standard form is written, x minus h. So this 2 here is your h, and this minus 5 out here is going to be your k. So this is why it's going to be 2, positive 2, comma minus 5 here for our vertex. Now, as for this extra 2 here, it does serve a purpose. We're going to get into that very shortly about what the purpose of this extra 2 sitting out here is going to be. But I just wanted to make sure that you understood where we got that first part from at the very least. Any questions about that? Again, guys, feel free to ask me anything if you have it, okay? Okay. Now, one of the important things in this section, of course, no problem, okay? No problem. Okay. Now, one of the things that's important in this section, of course, is we need to gather a lot of information, because what we're going to do here in this section, of course, is just to go ahead and change it to maybe something in a standard form, acquire some information, and graph the parabola. So instead of just guessing where the vertex is, now we have a way where we can say, oh, definitively, I know for a fact that the vertex is here. And then you can build a parabola based off of that. So those are definitely the coordinates of the vertex, yes. So the vertex is 2 comma minus 5. So again, rather than guessing where things have moved around and all that stuff, you at least have a very good idea about where to start. You know where, like, aka the center of that parabola is going to be, whether that be the highest point or the lowest point of that graph. All right, so that's a really, really easy to do if you kind of get it into that form. But we need some additional information, of course, to put together the parabola, so we have an expectation in our mind. All right, so that's what question 4 talks about. What information do we need in order to graph quadratic functions? Okay, so the first thing here will be the vertex. Okay. Second will be which way the graph opens, all right? So it could open up, it could open down. All right. The next one here would be x and y intercepts. So those are very helpful. All right. Those are things that we need. If it's if I guess I could put it here if possible. Y-intercepts for sure, you can easily find that, but x-intercepts sometimes may not be possible depending on the parabola. And of course, any additional points. Okay, so any additional points that we need to make the parabola, we go ahead and put that together, no problem. Okay, so let's take a look here, and let's see what we're working with here in terms of each of these individual points. Now we've seen a way of how to find the vertex, okay, by doing this, completing the square part. Let's take a look here, and how do we know which way the graph opens? Well, let's talk about the A part here in our standard form here, or talking about the same A here we have in ax squared plus bx plus c. All right, so those are the same exact A's. Now, clear that out. So if we have ax squared plus bx plus c, or again, a times x minus h squared plus k, either way, this a has the same representation. Now, what it depends on is what a is as a number. So if a all right, try that again. Yeah, that's a bit better. So if a happens to be positive, so it happens to be bigger than 0, it's positive, then the graph opens up. Arg. Yeah, let me make this bigger here. So the graph will open up. So it'll look like basically this, okay? That's what generically the graph will look like. If it opens down, if it is less than 0, then the graph opens down. And so it'll look like this. All right. So what this will do is give you a good template in your mind to be like, okay, I kind of have the expectation, I know what this graph looks like, and then there's going to be some points there, of course the vertex and some points, and you're like, okay, I could put that together as long as I have it at matching the expectation that I have here as it matches. So that's essentially what we're looking for here when it comes to A and which way it will open. Again, it will open up or it'll open down. Okay, one of those two things. Okay, questions about that before we move on? Okay, hopefully that's pretty easy so far. Alrighty, let's put that that way. All right, cool. Okay, let's go to the next question here, which is number 6. Okay, all right, so what is the axis of symmetry? All right, so this question here is incredibly boring. That's probably the most boring question in the class. Yeah. All right. Let's do this very boring question and we'll move on with our lives. All right. So the axis of symmetry Hereby, I'm going to label this as AOS for axis symmetry because I don't want to keep typing this out. Is always the x value of the vertex. Thanks, Cybor. I appreciate it. So, whatever the x value of the vertex is, we're going to go ahead and, hey, man, hey, if you want to learn, I'm down with that. All right. So basically, take our last example there. So our last example, we found our vertex to be 2 comma 5. So that was 2 comma minus 5, sorry. So if our vertex here, so example here, the vertex we found here was 2 comma minus 5. So essentially, at the end of the day, the axis of symmetry here is the most incredible thing you'll ever see. It'll be x is equal to 2. It's just the x value of the vertex. And by the way, yes, it will have to be written as x is equal to 2. So be sure you write it that way. This is the most. This particular question is drier than the earwax coming out of my ears. Okay, that's how dry it is. It is It is super dry. Um, we'll put a note there. You find that super exciting? Oh man, holy cow. Mind blown. And here they told me I was crazy to do this job. Look what happened. Look what happened, okay? I did some math major, and magically, many years later, nearly 20 years later, I'm still just as crazy as I was back then. All right. I mean, I remember playing video games in the middle of my math class. That was great. Great. I love doing that. That was just wonderful fun. Anywho, um, let's see. I remember teaching a review class after a tornado. That was interesting too. I taught a class in an earthquake. That was pretty cool. What else did I do? Oh yeah, I remember. I threw my shoes off in the middle of a class once and walked around barefoot. That was another one. Yeah. Mm. Good times, good times. Good times indeed. Yes, I did. I taught a class during a pandemic. This is true. This is true. I've taught students over a cell phone, so one person could make it to my Valorant stream if we get ahead. Uh, I don't know. Maybe a Fall Guys stream. I could do a Fall Guys stream if you want. I'm not very good at Valorant at all. You'll see me just act like a noob all the time. But yeah, I mean, if we get ahead enough, yeah, maybe that's possible. That's possible. I wouldn't mind that. Gotta be realistic there. Bam. Alrighty. Uh oh man, I'm getting in so much trouble. Alright. Let's take a look here at the next question. Okay, then we're gonna start putting some stuff together here. So it's kind of like a lot of stuff to do, and then what's you guys? Look, don't rage. Look, the purpose is just to have fun. All right. I know there's a lot of tryhards, but you know what? At the end of the day, that's okay. You know, just have fun playing the game. Like a game is just made for fun. You know, don't get too toxic. All right. At times you're gonna get toxic, but you know this isn't like competitive Overwatch. All right. I'm just saying. Okay, let's look at number 7. Number 7 says, "What is the shortcut to getting the vertex of a quadratic function?" Okay, so we talked about one way to convert from the general form into the standard form. Now, that was one way we could get to the vertex of that particular quadratic equation. However, there is definitely going to be a way to do it in a nice shortcut method. All right. So let's talk about the steps here on how to do that. So what we're going to do here is we're going to actually write out a example here for this, okay, and then I'm going to write the steps out here on the sheet here. So we're going to find all the information that we find necessary. So we're going to find the vertex, we're going to find the axis of symmetry, we're going to find like everything here, and then put it together all in a graph, and you'll see exactly what we're doing to kind of put it all together. Okay, so um, that's basically what we're doing here for this example. So let's go ahead and do a problem right now. Which one would be good? Sure, that one's not bad. Let's do that one. I want to pick one that's actually pretty straight here. Okay, that's fine. All right, that one's good. All right. Okay. let's go ahead and do this next one out here. So we got x squared minus 2x minus 15. Okay. So let's go ahead and see how we can do the shortcut version to getting the vertex here and start putting some pieces of the puzzle together. All right. So let's do step 1. Step 1 here is to find the vertex, okay? To find actually, let me be more specific here. To find the x value of the vertex. So just the x value, because remember, the vertex is a point. Okay, so remember, the vertex is a point of x comma y. So we're going to actually find each one of those points separately, okay, in order to do this shortcut. So we're going to find x first, and then we're going to find y. So to find the x value of the vertex, we must, to find the x value of the vertex, x is going to equal, and actually, let me put that on math type there to make it a little nicer. X will equal this little guy here. Negative b over 2a. Okay, so negative b over 2a is going to be the x value of the vertex. All right. So if that happens to be the case here, let's go back to our example here. So first and foremost here, let's label our things here. What is a? What's a going to be here? What's a according to this equation or function, quadratic function? 1. Correct. Okay. What is b? minus 2. Okay? And C, we may or may not use C, but just having there, minus 15. Good. All right. So let's go ahead and do negative b over 2a first. So that's going to be step 1. Let's find the x value of the vertex. So let's do negative b. So we have negative 2 over 2 times 1. Okay. So here we have a negative 2, which is positive 2 over 2. So in this case here, the x value of our vertex, just the x value of the vertex, is equal to 1. So far what we found here is that the vertex here is going to be 1 comma something. We don't know what that something is, but we're going to find out in just a moment. Okay. Let's go to step 2 and let's see how we find the y value of the vertex. So to find the y value of the vertex, okay, and let's go back to math type here. Y equals, and y is going to equal f of, oh, actually, put that in like this and like this. All right. F of negative b over 2a. So what essentially this part means specifically is i.e., plug in the result of step 1 into the original function to get the y value. Okay, that's essentially what that means in a nutshell. All right. So all we're going to do here in this problem is going to be here in step 2. We're just going to take our 1 and plug it into f. Okay, that's all we're going to do. So let's see what we get. So we get 1 squared minus 2 times 1 minus 15. So if we do this out, we get 1 minus 2 minus 15. And so this equals minus 16. All right. So there we go. We have our vertex. Our vertex here is at 1 comma minus 16. All right, questions about that? Hopefully that's not too bad. Hopefully pretty straightforward. Where are we at? Oh, stamps. All right. Guess they like what he had to say. All right. All right. Let's go ahead and so you just plug in x. Yeah, you just plug in what you got for x in the previous step. So that's why I plugged in 1. Because I got 1 here, I just plug it into the original function, and I get the y value out. Remember, f of x is the same thing as y, right, Jess? So if I just plug in 1, I get the y value of the vertex directly. So I don't have to do like a ton of work. So that's why it's a shortcut. You don't have to go through like the completing the square part. The completing the square part is a pretty big, yeah, the completing the square part is a pretty big pain in the butt, like without question. So if we're following the mantra here of this class, which is the laziest way is the best way, then yeah, then this is the then this is the best way. I mean, it's true. It's so true. If I can find an easier method consistently to do the same thing, why not? Right? I mean, I'm down. All right. All right. So now we found the value of the vertex. Okay. Now let's find additional information. So I'm going to add a few more steps here, but this is kind of like away from the vertex now. Now that we've determined the vertex here, all right, so let's go to step 3 here. Step 3 here, after finding the vertex, determine if the graph opens up or down. Okay, so let's go ahead and do that here in this case. I'm going to make this a bit bigger, so let's do that. Boop. All right. Make this bigger here. There we go. All right, zoom in there. Okay, so let's do step 3 here. So how do I determine if this graph, how do I know which way does this graph open up? Does this graph open up or open down? It opens up. Oh, sorry, Chase. Mubby. Um, so this graph will open, I'll move this over here. This graph will open up. That's correct. Okay, that is correct. So this graph will open up. Why? Because? because just because magic things happened, okay? That's what happened. Yeah. Yeah, because A is bigger than 0. That's correct. Yes. A is positive, okay? I see the troll patrol is out in full force. All right. Uh A is equal to 1. So A is bigger than 0. Okay, good stuff. All right. Bueno, bueno, bueno. A is positive. Perfect. Perfect. All right. Next, step 4. So this is kind of like step 4 is basically we're gonna find the y-intercept. I always put this as a kind of a separate step here on purpose. You probably say, actually, no, I take that back. I take that back. Hang on. I'll do that as the next step. Yeah, the next step. All right. Find the axis of symmetry. All right, find the axis of symmetry. So, what is the axis of symmetry here, according to this problem? One. One is correct. You're missing one part of that, though. What should equal 1? Don't forget the formatting here. I only asked this because the homework is very particular. So personally, I wouldn't care, but again, the homework's very particular. So x is equal to 1, right? Right. So they will ask you, be like, yeah. So I know this is like, oh, why are you being so hard? Like, nah, it's just the particularity of some of the questions they ask you. So, all right, let's go to step 5 here. Find the you know what? Find the x and y intercepts. You know what? Oh, yeah. So the reason why we want to find x and y intercepts, if it's possible, is because of the fact that it'll give us additional points without having to do any more work. Like before, when we graphed like quadratic equations or whatever, we went ahead and put an XY chart. If we have the X and Y intercepts, we have additional points, and then we don't need like an XY chart for any additional points. So it's a way to basically kind of find those extra points there. Now, in this particular case, if we're doing step 5 here for this equation, oops, sorry about that. Let's put step 5 over here. Okay, let's do the y-intercept first because it's the easiest. All you do for the y-intercept is plug in 0 for x, so x equals 0. So if you plug in 0 for x, f of 0 is equal to 0 squared minus 2 times 0 minus 15. And so here you get minus 15. So that's going to be our y-intercept, 0 comma minus 15. Now the x-intercept may or may not be possible. So the x-intercept is a little bit more tricky if you don't have a very nice equation. Remember, this could involve doing the quadratic formula if necessary to find the roots, and it could be some complicated root, or heck, you may not even have any roots. That's entirely plausible. In this case here, we set y is equal to 0, and so we have x squared minus 2x minus 15 equals 0. This one's pretty simple, so this one does factor. This factors to x minus 5x plus 3. And so here we actually end up with two answers for x. We get x is equal to positive 5 and x is equal to minus 3. So we have two x-intercepts here, which is going to be 5 comma 0 and negative 3 comma 0. Finally, step 6 is to graph the function. All right. So now you can go ahead and put it together because now you got enough information to go ahead and be like, okay, here's the graph of the function. Now we have enough information to put it all together. Okay. So let's take a look at what that graph looks like. And again, just a kind of a hand-drawn graph, pretty much. So it's not going to be super great, but it works. So let's expand this canvas a little bit more. Need a little bit more space. There we go. Okay. It will be great. H. uh, It'll be pretty great. So 1, 2, 3, 4, 5. So we have 5 comma 0 is one of our points, as we have down here. Negative 3 comma 0 is another point. 1, 2, 3. There we go. Ba-bam. We have 0 comma minus 15. So let's go minus 5. This will be minus 5, minus 10, and just paraphrase here a bit, minus 15. And we'll put a point down here. And then finally, we have 1 comma minus 16, so which was the vertex here, 1 comma minus 16. So we took, as you can see here, we have actually 4 points, right? You can see we have 4 points here. So 1 comma minus 16, which is right about here-ish. And so as you can see here, you can connect the dots and put it as a nice little parabola. Okay, and there we go. We also see that the graph will open up as was expected. And just to let you know, what does the axis of symmetry look like? It's just a dotted line that goes and cuts the parabola in half. Like I said, I don't care about it too much, but you know, it basically kind of goes like this. This is what the axis of symmetry looks like. Just a dotted line that cuts the parabola in half like that. Okay, and so that is how we can go ahead and graph these dudes. All right. Any questions about that? No? Okay. Hopefully that wasn't terrible. Hopefully. All right. Okie dokie. All right. So that was question number 7 for this. Yeah, I'm pretty sure. I'm pretty sure everybody would be pretty happy with the shortcut there. You know, absolutely 100%. I'm down with the shortcut if you are. um. All right. Let's take a good look here at number 8. What is the maximum and minimum? What is the maximum and minimum for a quadratic function? Okay. Now, the answer to this is really easy, but this is more related to kind of like an application problem here. So, let's talk about that here in this instance. So, a maximum or a minimum for a quadratic function is the vertex of the parabola. Okay, so if you find the vertex of that quadratic function, then you're going to find the minimum or maximum there. All right, and where that's going to occur. Either you're going to get, it opens up where you're going to get a bottom of a bowl, or it's like the top of a hill if it opens down. Okay, so the real question is, what's an example where we use this, a little bit more carefully? Let's go ahead and do that right now. All right. Okay, so I'm going to go ahead and type out this example here. Um, so, and yeah, okay. A shot put is released at a particular angle and its height in feet can be modeled by, and I'll go ahead and write this in here. So f of x equals -0.01 6.1. All right. So let's say you have this model here for this shot put being released by some Olympic athlete or something like that. And this is the equation that you're given here. All right. Now we're going to answer several questions in relation to this equation that we're randomly given. Okay. Letter A, what is the maximum height of the shot put? Okay. And how far from its point of release does this occur? Okay. So let's answer this first question here. What is the maximum height of the shot put, and how far from its point of release does this occur? Okay, so if you take a look at that question there, all right, as you can see, again, we're going to find the vertex of this particular parabola. Again, a shot put's going to go in an arc like this. Okay, that's what every, if you just toss a ball up, it's going to go in an arc in some put type. Now, a shot put being a very heavy weighted kind of bronze type ball, yeah, that's still going to go in an arc, just maybe not as high. In any case, uh, what should we do? How do we find the vertex here? What do we need? Okay, negative b over 2a. Very good. And okay, b over 2a squared. No, you got those two things mixed up there, JTS. Okay, you're thinking about completing the square and finding the x value of the vertex mixed together. You just want to use negative b over 2a like we have up here, as you can see up here in question 7. All right, no problem. Just here to make sure we don't fall off the path there. Okay. So here we're going to have a. Let's pick out a. What's a going to be, by the way? What's a? What's a going to be here? Minus 0.01. Okay. B. .7. Excellent. And let's go with C. What's a C? 6.1. All right, good. So if we need this last part here, we could possibly need that there. All right. So we have, everybody was right. Got your numbers in. Perfect. Now we're going to do negative b over 2a, okay, to find our x value of our vertex. All right. So let's go ahead and see what we get here. So we get negative 0.7 divided by 2 times negative 0.01. All right. Does anybody have an answer for me here for x? Okay. X. Okay. What do we get for x here? .0035. Not sure about that one, my friend. Make sure you enter this in. This uses your brain too much, man. I don't know what to tell you here. Make sure you put it in correctly. So if you want to put it in the calculator correctly here, you're going to have negative 0.07. So the calculator is not very smart. I'm just going to point that out there. You got to tell it what to do. So when you do the bottom part here specifically, so this is what people unfortunately do, is they put exactly what you kind of see here. All right, put another set of parentheses on the bottom here. So what you have is you should have parentheses 2 times, and then put parentheses negative 0.01. And then close the second set of parentheses there. And you'll notice a difference in your answer. All right, 3.5. All right, so that's 3.5. We're almost there. 35. There we go. We got it. 35. All right. I think you accidentally put 0.1 instead of 0.01. I think that's why you got 30.5, 3.5. All right, so we got 35 here. So, I think that this is one of those problems where one of the examples I like to do that kind of showcases why you need to be really extra careful with how you enter things into the calculator. So yeah, so I actually put a note with this one here, specifically. Like, it's not hard. You can see where you need to put the numbers here, but watch out about how you enter in numbers in your calculator. Okay, like I said, the calculator is not a very smart piece of machinery. You have to put it in the correct format to give you the correct answer. Sometimes it just means adding a little bit more, like an extra set of parentheses around the bottom, and basically making sure that those multiply first before you divide. If you do it without parentheses, it'll multiply and then divide, and that's not what you're after. So okay, now we need to find y here. What's the y value of the vertex? How do we find that? What do we do with that 35? Plug a 3.5 into the function? We got 35 here. I think you meant plug 35 into the function. All right, there we go. So we're going to plug 35 into the function. That's right. So let's go ahead and, again, purely a calculator after this. So all right. And does anybody have an answer for me here? What do we get here? 30.25. 30.25. Let's see. Is that right? 30.25. Let's check that. Oh, yeah, then that's going to be off if you got the square. All right, there we go. Nice. 18.35. Okay, good. All right. So what we have here is that the max horizontal distance is 35 feet at when the maximum height occurred after 35 feet. So the max height equals 18.35. And then 35 represents the horizontal distance where the max height occurred. Okay, so that's part A. All right. Any questions about part A? Okay, let's go ahead and do letter B then. Okay. Actually, let me check that really quick. Ah, okay. Yeah. Okay. So letter B. What is the shot put's maximum horizontal distance? Uh, or in other words, the distance of the throw. Okay. Okay. So in this particular case, what are we trying to find? In this case here, when you see a question like this, what we are specifically trying to find here is we are trying to find the x-intercepts here. So the key here is need to find the x-intercepts. All right. So that's what we want to be doing here in this particular case. All right. So if we find the x-intercepts, we should be good to go. Now, of course, we can't factor this. So if we're going to find the x-intercepts here to find out the answer to this question here, we're going to go ahead and use the quadratic formula. Okay. So we're going to go ahead and use the quadratic formula here. So in this case, so again, our good friend, the quadratic formula, if you don't remember, here is the, let's, I know they put the whole thing down, so no. Like I know you guys had it on here. Nah, that's derivatives. Here we go. All right, there we go. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so that's going to be our quadratic formula, buddy. All right, it shouldn't be too bad. It'll be pretty straightforward. So let's use our a, b, and c here, and we're going to go ahead and find out what we get. Okay, so specifically here, we're going to get, let's met this out here. Okay. Okay, so we have negative b plus or minus the square root of b squared minus 4ac. So again, negative b plus or minus the square root of b squared minus 4ac. Okay, and then all that over 2a. Okay, so that's what we have here in this instance. Okay. All right, so here we got, let's go ahead and just clean this up a bit. So we got negative 0.7 plus or minus the square root of 0.7, and then we'll go ahead and just see what we get here. So we get minus 0.244 all over minus 0.02. And you're going to get two answers for this, okay? All right, specifically you'll get two answers. Let's go ahead and see what we have here. Okay. All right, there we go. Wait, what? All right, hang on a second. Sorry. Oh, that's what I did wrong. Let's do that again. There we go. Okay, so I get two answers here for x. I'll get minus 7.8369, and I'll also get 77.8369. Okay, so I'm going to get both of those particular answers here in this instance. Oh, yeah, you're right. You're right. I'm sorry. I forgot that, JTS. What's going on here? Yeah, we're doing a math class, yo. Um, Howdy yourself, Buffle. We're doing some college algebra, my dude. College algebra. All right, so we're going to choose the 77.8369 because that was the most realistic one. Obviously, that will be the furthest. That'll be the distance there after doing that out. So you should be good. All right, any questions about using the quadratic formula to find our maximum horizontal distance? No. All right. Good beans. All righty. Yeah, okay. All righty. Any questions about the section? Okay, yeah, that's true. That is true. All right. All right. So let's look at this next one here. Let's look at the next section here. We're going to do just a few questions from here. All right, just to kind of, we're going to do a few questions from here just to kind of get used to the concept here. But we're going to expand upon polynomials a lot in this chapter. But at least let's get the basics down here. So I'm just going to go ahead and do, say, the first three questions here. And then we'll go ahead and wrap stuff up. Can you scroll back to the last question? Okay. Yeah, sorry about that. This right here? I think that's what you're looking for. Or was it this? Cool. All right. Nice. Okay. Let's take a look at question number 1. Question 1 says, what is a polynomial function? Okay. So we need to be a little bit specific about this definition. So I'll go ahead and put this down here. A polynomial function is a function which has I guess I want to say which has coefficients, coefficients being numbers next to powers here, coefficients of variables, all right, and all the powers of the variables are non are not, that's what I have to say, non-negative integers. Okay, so A polynomial function is a function that has coefficients of variables, and all the powers of said variables are non-negative integers. Now, there is a very long way of writing out a polynomial, and that would take me a little time to do. Just kind of write stuff out. But I think if we look at some examples here about what a polynomial specifically looks like, we'll go ahead and take a look here. Let me map that out there. Where's that? Okay, there it is. Okay, so here's an example of a polynomial function, and I'll put it over here. So you can have a function that looks like this. 5x to the third minus 7x squared, okay, plus 2x minus 11, okay? This is an example of a polynomial function, all right? There's nothing much to it. Each power here in this particular function has a coefficient. It could be 1, by the way. And each power here that you see, 3, 2, 1, and heck, even 0, are non-negative integers. However, on the other hand, if I were to write this out, so let's take this polynomial here, or this function, I should say. What if I said 5x to the minus 2? If I have 5x to the minus 2, this is not a polynomial, okay? Because in this case here, the power is negative. And since the power is negative, that does not qualify underneath the definition of a polynomial. Okay, so in this case here, this is going to be not a polynomial. Let's go ahead and look at a couple more here, of course. Okay, so another example here. Let's see. I'll have you guys answer this. How about so yes or no, is this a polynomial? Say yes. See no. So one and one, no and a yes. What do the rest of you think? Say no. Okay, 2 no's, 1 yes. 3 no's, 1 yes. 4 no's, 1 yes. All right, 4 no's, 2 yeses. All right, 5 no's, 2 yeses. Anyone else? Okay, so the answer to this is going to be no. This is not a polynomial. The answer is 9. Yes. The answer is 9. The answer is no. This is not a polynomial. And the reason why this is not a polynomial is because if you look carefully at the definition, notice here that these have to be non-negative integers. Okay, which means they have to be like 1, 2, 3, 4, 5, or 0, but they cannot be 1/2. Okay, so 1/2 is a no-go based on the definition that we have here. Okay, so that is definitely not a polynomial because of that. Now I'm going to show off one more here, and then you could tell me yes or no if it's a polynomial or not. Is this a polynomial? Yes or no? Five plus 1 over x. All right, we got 1 for no, 1 for yes, 2 for no, 1 for yes. No, there's no okay, 3 for no, 1 for 1 for yes. Anybody else? All right, we got 4 no's, 1 yes. Okay, so the answer to this one here is going to be no. Now the question is, why is that the case? Well, the reason why this is the case is because in this particular instance, you can rewrite this equation here as 5 plus x to the minus 1 power using the rules of exponents. Remember that you can move from denominator to numerator, and that could actually be a negative exponent because of that fact. If f of x was equal to like 5, this is a polynomial. That's fine. But if it had the 1 over x written in there, uh, you know, then no, that's a no-go. All right, any questions about that? No? All right. Let's go ahead and move on here. All right, 2 and 3 will be very quick, so they should not take so much time. What is the degree of a polynomial? All right, so the degree of a polynomial is the highest it can be combined power in the polynomial. So that's the degree of the polynomial. So if I had, let's look at another example here. If I have this, for example, let's say I had f of x is equal to 5x squared minus 6x to the third plus 10x minus 11. If you looked at that, what would be your degree of this particular polynomial? What's the highest power that you see in that polynomial? Yeah, the answer's 3. Exactly. So even if it's written out of order, you just look for the highest number, highest power, and that's the degree straight up. Like, you don't even have to try. All right, it's actually pretty straightforward. Now, as I put here, I said combined powers. Sometimes you may see polynomials in the future that could have an x and a y in it. So it could have 2xy minus 5x squared y to the fourth plus 16x to the seventh y to the third. Maybe you have some random something like this. Now in this case here, the degree here in this particular case is going to be 10. The degree here is 10 because we actually combine the powers of x and y, and we see which one is actually the biggest. So in this case here, I have x to the first, y to the first, so this is degree 2, a degree 2 term. Here I have x squared and y to the fourth, so I have 2 plus 4, which is 6. And here I have x to the seventh and y to the third, so 7 plus 3 is 10. So my degree is 10 for that particular polynomial. Okay, so just pointing that out there about what that is. Okay, let's move on here to the last question. We're going to be using degree in certain aspects, so at least knowing what degree is important. So we'll be using it as a way to check certain things. All right. So the last question we're going to do here for today is, what is the leading coefficient of a polynomial function? All right, so the leading coefficient is the number in front of the variable that has the highest power. Okay, that's pretty much it. So if I were to look at this, let's go back to this here for just a second. Go back to this example here. What is the leading coefficient of this polynomial? What is the leading coefficient of that polynomial? Ten? Try again. We have our degree is 3, right? So we want to have the highest. It's the leading coefficient is the number in front of the variable that has the highest power. So we want to look at the highest power. That's how we determine degree. What's the number in front of that x variable then? Okay, that's correct. It is minus 6. All right, don't forget the sign here, guys. Yeah, minus 6 is going to be the correct answer. That minus 6 is it next to the highest, the variable that has the highest power. In this case, 16 would be correct, Planet. If we were to look at this last one here, 16 would be the leading coefficient. That's absolutely right. All right, so I would say, yeah, that's absolutely right. In that case, the leading coefficient here would be positive 16 in that case, because that's where we find the highest combined power there in that particular instance. And so what we're going to be doing here next time is taking a look at the leading coefficient and seeing how we can actually gain some extra information off of it in order to determine graph behavior. Okay? Any questions about that? Oh, no, it's okay, Planet. It's not your fault. You're still right, so it's all that matters. Okay, so we're going to end off here for today. Again, I hope everybody got their email that the test and the homework has been extended. Okay, so you guys should be good to go for continuing moving forward here for the week. Okay. Yeah, and we're going to come back on Thursday, and we're going to continue off here on section 3.2, and we'll move into section 3.3 right after that. Okay, I want to thank everybody for coming out today once again to the stream. All right, this will be here on Twitch. When is the test due again? It will be due next Tuesday at 11:59, so the 29th. I sent an email to everybody, so if you check your student email there, I sent an email to everybody just letting them know of the change. Yeah, I did it pretty recently, so maybe you haven't had a chance to check your student email. Yeah. Oh yeah, some of you came in late. Yeah, yeah. That kind of happened. Check your student email. Yeah. No problem. This might be the only time I'll extend the due date, but you guys got to get in the swing of things once we get going, okay? All right. So I will leave it off here for today. Thank you very much, everybody. We will see you all here on Thursday. Have a very wonderful afternoon slash evening. All right, and enjoy yourselves. All right. See you next week. See you next week. You mean see me Thursday? Thursday, my dude. Thursday. I'm not gonna be here next week. Come on. No. Thursday. Come back in 2 days from now. Planet. Please. All right. We'll see you all Thursday. Thursday, everybody. All right. Take it easy, everybody. Have a great one. Okay. Bye.